Optical wireless communications, opportunities and limitations. Optical wireless communications, opportunities and limitations. In the past few years, optical wireless communication, (OWC), has gained significant interest from researchers and scientists. OWC uses light as a medium for transmitting data instead of electromagnetic waves. The process involves converting electrical signals into optical signals and then transmitting them through the atmosphere or a fiber optic cable. Opportunities of OWC. There are several advantages of using OWC over traditional wireless communication systems. One of the significant benefits of OWC is the availability of the spectrum. Optical frequencies have a higher frequency than radio frequencies, which means that they can transmit more data per second. OWC can provide high-speed data transfer, which can improve data rates of up to several gigabits per second. A rate that cannot be achieved with traditional wireless communication technologies. Another advantage of OWC is its security. Since OWC uses light rays, the transmission signal is harder to intercept or interfere with, unlike traditional wireless communication systems that use radio waves. This makes OWC a preferred choice for mission-critical applications such as national defense, banking, and healthcare. One of the most significant benefits of OWC is its low operational cost. Optical wireless communication systems do not require any licensing, which means that there are no fees and no need for regulatory compliance. This is in contrast to traditional wireless communication systems that require a spectrum license, which can be expensive and time-consuming. Limitations of OWC. Despite its benefits, OWC has several limitations that have to be considered. One of the significant limitations of OWC is its susceptibility to atmospheric turbulence. The atmosphere can cause the light waves to scatter, which results in signal degradation, making it difficult to achieve a reliable and stable transmission. Another limitation of OWC is its limited range. OWC devices operate on a line-of-sight loss basis, which means that they require direct visibility to transmit data. This line-of-sight problem limits the range of OWC devices compared to other wireless communication systems that can transmit data over longer distances. Thirdly, OWC is also susceptible to interference from artificial light sources. OWC devices use light waves, just like artificial lighting systems in homes and in cities, and this can cause interference with the transmission signals, resulting in further signal degradation. Finally, the deployment of OWC infrastructure can be challenging. OWC devices require the deployment of more access points than traditional wireless communication systems, making the deployment more expensive and challenging. Overcoming the limitations of OWC. Scientists and researchers are working towards overcoming the limitations of OWC to enable it to achieve its full potential. One solution to the line-of-sight problem is the use of reflectors or mirrors. The reflectors redirect the light beams, enabling the transmission of data over longer distances and past barriers. Another solution to atmospheric turbulence is the use of adaptive optics. The deployment of OWC infrastructure can be addressed by using the existing infrastructure, such as street lights and buildings, as access points. This approach reduces the cost of installation and deployment and enables OWC systems to cover broader coverage areas. As AUK continues to develop and mature, it is expected to play a crucial role in the advancement of various industries. One area that stands to benefit significantly from AUK is autonomous vehicles. As self-driving cars become more prevalent, they will rely heavily on data transmission for real-time monitoring and information exchange. AUK's high-speed data transfer rate and low latency make it an ideal choice for data communication in autonomous vehicles, enabling them to react quickly to changing road conditions. AUK can also revolutionize healthcare by enabling wireless communication between medical devices and improving the effectiveness of telemedicine. Telemedicine allows patients who live in remote or underserved areas to access medical care remotely. Another area where AUK can be beneficial is in the IoT industry. With the exponential growth of IoT devices, there is an increasing need for efficient data communication systems. AUK's low cost, high speed, and high security make it a suitable option for transmitting data between these devices, enabling them to communicate seamlessly and efficiently. The potential of AUK to revolutionize various industries cannot be overstated. It is expected to bring about a paradigm shift in wireless communication, offering better data rates, security, and reliability. The line-of-sight limitation that it currently faces can be overcome by using reflectors, while the use of adaptive optics can help address the issue of atmospheric turbulence. Moreover, the limited range of AUK devices can be addressed by utilizing existing infrastructure, such as buildings and streetlights, to distribute access points. While AUK's susceptibility to interference from artificial light sources may be a challenge, it is not insurmountable, and measures can be taken to mitigate its effects. As AUK technology evolves, it will play an increasingly crucial role in various industries, such as autonomous vehicles, healthcare, and IoT. With its high data transfer rate and low latency, AUK is an ideal communication system for autonomous vehicles, enabling real-time data transmission and quick reaction to changes on the road. It is also suitable for healthcare applications, where it can enable wireless communication between medical devices, improving the quality of care and reducing the need for patients to travel. Furthermore, AUK can be beneficial in the IoT industry, enabling efficient data communication between devices at a low cost. As AUK continues